For those of you that missed class today, I want to just briefly review with you what we um, went over with our phase diagrams and our heating curves. The phase diagram that I gave you that looks like this in class, um, what we did is we labeled the areas where you find your states of matter and how to interpret the phase diagram. Notice the phase diagram is a graph of pressure versus temperature. And again, this is a review of the notes you watched last night. So if you missed class today, this is the little lesson on the review for phase diagram and heating curve. Phase diagrams always have this typical shape. It's kind of like a Y shape or a backwards Y shape. So there's typically going to be three sections. Sometimes there's only two, but most often there's three sections that you see in these open areas, and I've kind of color-coded them so you can see them a little better. But in this first region, you will always have the substance existing as a solid at the temperatures and pressures that you would encounter in this region. Over in this section, it will always be a liquid. And down below here, below at the bottom section, it will always be in the vapor or the gas phase. Then we talked about if you were actually on the line. If you go from a solid to a gas and have to cross that line, then the substance is undergoing sublimation. If you go from a gas to a solid, we learned that that phase change is called deposition. So if you happen to encounter any points that lie on the line, that's where your phase change is occurring. So you have a solid in equilibrium with the gas. As you cross the line solid to liquid, we call that melting. And then of course we all know that if you go backwards, liquid to solid, that is called freezing. So if you cross the line here between the solid and liquid phase, you have a phase change occurring, and you have two states of matter. Solid is in equilibrium with the liquid. Finally, if you cross from liquid to gas, when a liquid changes to a gas, that is called evaporation or vaporization. And if you go backwards from the gas to the liquid, crossing the line, that's when you have condensation. On the line itself, you always, again, have two states of matter because you're crossing between two phase boundaries, and that's when you have a liquid in equilibrium with the gas phase. There were also two special points that we learned about, and we wrote down our notes. One is this point here, where all three lines come together. That is called the triple point. And I remember because three lines come together at this point, triple point, and that's where you have, if you were to read the graph and look down at whatever temperature this would correspond to, and normally you would have numbers here, that would be the temperature. And if you read over to your pressure axis, that would be the specific pressure that you would see this substance having solid, liquid, and gas at the very same time. Up here at this highest point, this was called the critical point. So if you read down here, whatever temperature would correspond here would be called your critical temperature. And if you read over to the pressure, this would be correspond to your critical pressure. The critical point, remember, is the temperature and the pressure past which only gases can exist. Okay? So the second diagram was the heating curve. Notice this is a graph of temperature versus time for the substance being heated over time. So we labeled these points A, B, C, D, E, and F. So on the heating curve, at the temperatures between this region here between A and B, this is where the substance is frozen, and we call that a solid. And then once you reach the point that we call the melting point, here this is water, so it's 0 degrees, you have melting occur, you have two phases. You have a solid in equilibrium with the liquid. This is where melting is occurring. Then, once all the solid is gone and you have just a liquid, the temperature begins to rise again. And then, of course, you reach your next phase change, which for water occurs at 100 degrees Celsius. This is where you have your boiling liquid. Liquid is in equilibrium with the gas. And it will continue to boil until all the liquid is gone. And then from E to F, that's where you have just the gas state existing. We also talked about the fact that the plateau that you see here, the melting plateau, is going to always be a shorter plateau, a shorter time span than the plateau that you see up here where the boiling liquid is occurring. And it's because in order to go from a liquid to the gas, you got to get your particles from touching to really, really far apart. So it's going to take longer to get them to spread apart. Whereas here, you go from a very rigid solid and you just have to get them to go to a liquid, but they're still touching. They're just not held in place. So you don't have to get the particles as far apart. We also reminded that the energy that is used during these phase changes has special names. Here, we call this the heat of fusion, and we abbreviate that delta H with a FUS as a subscript. That's the energy involved during the melting or the freezing phase change. And then the energy that is used here during the phase change of boiling, that's called the heat of vaporization, delta H with a VAP. All right, so that is the video lesson, a review of the heating curve and the phase diagram. We also in class today, we worked on your race to the finish review sheet. We did section Roman numeral 1, and we're going to do Roman numeral 2 in class next time. Thanks. See y'all later.